speaker is Anmar Dulami, and he is going to speak to us about development of sustainable cold asphalt concrete.
Oh, okay. That's okay. Where's the pointer?
Okay, so there's your pointer.
Where is the light? The light.
And then you've got your laser pointer there.
Okay.
Yeah. And then you select your presentation.
That one. Good afternoon. My name is Anmar Dulami, and I am from the School of the Built Environment. My presentation today is about the development of sustainable cold asphalt concrete binder course using waste fly ash and newest activator, and why this process is very important to apply in the future. The outline of my presentation will be introduction, a brief description about the warm, hot and warm and cold mixed asphalt, why cold bituminous emulsion mixture, and we have a multi-phase solution, enhance the cold bituminous emulsion mixture by adding at the first stage waste fly ash, and activate this waste fly ash by a new waste activator, and conclusion. Let's start with the production of the hot and warm mixed asphalt in Europe. This figures according to EBA, European Asphalt Pavement Association. We can see in 2013, the production of hot and warm mix in Europe is more than 275 million tons per year. And there is a restriction on using hot mix because of the CO2 emission and the problem in controlling the temperature when hauling long distance. So you can see the emission, and you can see we need to keep the temperature, and it is not easy. What is called mixed asphalt? From this figure we can see the conventional hot mix is the mixing of heated aggregate with the bitumen at a temperature between 150 and 180. While for both warm mixed asphalt and hard form mixed asphalt, we need to mix the aggregate and the bitumen in a temperature approximately between 100 and 140 for the warm, and for the half from 70 to 100 degree. Cold mixed asphalt, to produce without heating for the aggregate and for the emulsion, it will be between 0 and 60. For our mixture, we produce our mixture at ambient temperatures, so there is no heating. So cold bituminous emulsion mixture are produced without heating for the aggregate and for the emulsion, and it contains graded mineral aggregate and bitumen emulsion with pre-water. If to compare between hot mix, I think there is a mistake there. Okay, to compare between cold mixed asphalt and hot mixed asphalt, in terms of energy required to produce each metric ton, we need 277 megajoule per ton, while for the cold mix, just 36 megajoule. In terms of CO2 emission, there will be about 21 kg per ton for the hot mix, while just 3 kg for the cold mix. In terms of safety, and the temperature to produce the hot mix, you can see the temperature is about from 140 to 180, and it depends on the viscosity of the bitumen, while our mixture at ambient temperature, there is no need for heating. But there are drawbacks for the cold mix. Suffer from three disadvantage: higher content for the compact mixture, and the weak early strength, and the long curing time. It will take from 2 to 24 months to get a good stiffness to compare with the hot mix. To improve the performance of cold mix, OBC, cement, used widely to enhance the performance, but to produce each metric ton of OBC, we need 1.5 ton of core material, and there will be about 1 ton from the CO2 emission, and we need energy about 5.6 gigajoule per ton. So there is a restriction on using OBC because of it is not cost material and because of the environment impact. Also, fiber reformist and polymers are used, but both of them, they are not cost-effective material. The third approach is LGMU approach, using waste and byproducts to replace the mineral filler. This is the gradation, aggregate gradation of our mixture. It is asphalt concrete 20 millimeter binder course. It is the most common type of binder course used in the UK. Our strategy is to replace this part. It is the mineral filler, which is here 6% from the mixture. This is a picture to know what is the fly ash. So we have a multi-phase solution when using cold mix with waste material, because there will be energy. It is energy efficiency. There is no need for heating, and it is cost effectiveness material because wastes are free, and there is no need to buy anything, and it is eco-friendliness. There is no CO2 emission, and we will save the natural resources. In terms of safety, it will be safe for the workers who work to mix and to apply the mixture. This is our result. We have here a 3 control mix. This is the first one. It is cold mix without any additives. And we have 2 hot mix, soft hot mix, and this is the hard hot mix. And we replace the mineral filler 1.5%, 3%, 4.5%, and 6%. We can see this is the result in 2 days, 2 curing days. We got more than 3,600 megapascal. To compare, this is the most common type in use in the UK. So in 2 curing days, we got about 80% improvement. This is the relationship between the curing days and the stiffness modulus. This is our optimized mixture. We can see this in 2 days, and it is in 28 days. It is more than the hard hot bitumen mixture. Now we apply new materials. We searched a lot inside the UK, outside the UK, to find an activator for our waste fly ash. So this is our optimized mixture. when we replace the mineral filler with 6%, when we apply just when we add 1% of a new waste material, I need someone if he can estimate the result. Okay, so with 1%, we got more than 5,600 megapascal, which is about 50% improvement. In 2%, we got more than 6,500, about 70% improvement. And in 3%, we got more than 100% improvement. So we have now a new promising material used for the first time in cold mix, and we can say it is Algamu new activator. In terms of water sensitivity, this is the cold mix, control cold mix, and this is the 2 hot mix control. This is the hard and this is the soft, and this is cold mix with waste fly ash. This is with additives 1% of Algamu, 2% and 3%. We can see that the wet stiffness, which is the blue one, is more than the dry stiffness. So our new mixture is more durable than the 3 control cold mix, the 3 control mixture, 2 hot mix and the cold mix. Conclusion: the new cold binder course enhanced the pavement performance in terms of stiffness and water sensitivity, and we have now economical solution, and there will be a reduction in CO2 emission. When we apply more than 3% of the waste fly ash, we got stiffness modulus more than the 2 types of hot mix. And when we add the Liverpool Mors activator, we got an inspiring result in 2 days. In terms of water sensitivity, we can see that the wet stiffness is more than the dry stiffness, so it is more durable. This means that the stiffness modulus ratio is more than 100%. Thank you very much. Any questions?
Questions, please?
Very good presentation. My question is, why do material, its strength is increasing with its age? Because normal hot mix, its strength is fixed.
Yeah, because our waste material is got a cementitious activity. So it's like a cement. We need to replace the cement that used in the previous to enhance the cold mix. So we replace the OBC and we put waste fly ash, and he got cementitious activity. So there is a hydration process, and there is a water, and there will be a enhance the stiffness.
So if there is no water, then there will be no increase in strength? If it is in dry weather?
Yes, you can see for the hot mix, from 2 days to 28 days, there is just a little variation in the stiffness because there is no water and there is no cementitious hydration activity.
So there is a chance to losing the flexibility nature of the material?
Now, in my research here, I use the Liverpool Mors and additives, and I start now to use it in the same 6%. Okay, so I will reduce the rigidity. I know what you mean. Yeah.
Any more questions? Olga.
Yes.
How do you measure that you actually achieving this?
How I will measure the CO2 emission? Because in cold mix, we don't need to heat the aggregate, or we don't need to heat the bitumen. We mix them in ambient temperature in 0 not zero, at room temperature. While in hot mix, you can see we need to heat the aggregate approximate to, for me, for the two control mix, one to 150 and the other to 175. Okay, and for the bitumen, there will be emission. I think you have, there's a picture missed in the second slide. There emission, and it is not safety for the workers. In cold mix, there is no emission.
So are you saying this process completely CO2 free?
Sorry?
Is your suggested process completely CO2 free?
Not 100% CO2 free, but if you compare between a mixture with 150 degree and with a mixture with 0 degree, you can compare.
So can you compare? Can you provide to compare this process?
The process?
Mix and cold mix.
Yeah. In CO2 emission, for my mixture, I didn't do that, but in previous, they say for the hot mix, there is emission about 36 kg per each ton, while for the cold mix, about 3 kg per each ton. Thank you.
Any more questions? Please.
With your second additive that you've added, as well as the fly ash, does that change the, is there a chemical reaction with the fly ash, or is it?
Yeah, it is a material with a pozzolanic activity. So this is, we increase the hydration of the first material when putting the second one. I can't say what is the material because I am in the middle of my project. Okay. They use normally not waste material. They use like silica fume, metacholine to enhance the performance of the cement when made a concrete. Now we replace that using a waste material, have the same property.
Any more questions? Please.
I think lunch is ready, so.
Thank you for your presentation.
Okay.
About the quality of the new mix, is almost the same of the hot mix and the cold mix. For example, can we use it in all countries? We have some very hot countries and cold countries. Asphalt, the quality of the sufficient, right?
Yeah. With the stiffness, we got stiffness more than the hot mix.
Yeah.
Regarding the water sensitivity, it is more than the hot mix. I have the result for the permanent deformation. It is excellent in permanent deformation. There is no rod depth. Okay. Maybe with 2 months, I will start the fatigue. So it is a promising material in the engineering properties.
Okay. Are we done with questions?
You have one.
Okay. At this time, I'm going to let you off the hook. We'll speak separately.
Okay.
Lunch is now served, so you're ready for lunch.
Okay. Thank you.